All right, next we have these questions 9, 10, 11, 12 that will be solving. It's binomial expansion, collaboration with binomial theorem. All right, so write down the value of a in the following. All right, so we have 50 and 13 there. They're telling us this is equal to 50 factorial over 13 factorial, then a factorial. What is the value of a? The only thing that they want you to do is to rewrite 50, 13 into binomial coefficients, which we know. If I rewrite this one into a binomial coefficient, I'll be getting 50 factorial over, then I'm going to get 13 factorial, open brackets, 50 minus 13 factorial. So this will give me 50 factorial over 13 factorial. So what is 50 minus 13? You end up getting 37 factorial, which corresponds to there. So a is just what? 37. You can do the same for part 2. It's still the same. 35a. All right. So this will be equal to 35 factorial over a factorial. Then you have 35 minus what? 35 minus a factorial. Okay. But remember, this is equal to this part here. Is equal to 35 factorial over a factorial minus, factorial, then 18 factorial. So this is equal to the entire part. So we are saying 35 minus a is equal to 18. Then you can solve for a. So we have 35 minus 18. So this should be able to give us 17. So you've seen, just the scenario is the same. All right, now let's progress to question 10. Having worked out question that one there, let's go to question 10. Question 10 is calculate the binomial coefficients. So let's start with 14. We want to calculate the binomial coefficient. All right, we know from the way to go that nk is equal to n factorial over k factorial n minus k factorial. Clear on that one? Good. We do the same here. We rewrite. It will be 4 factorial over 2 factorial, then 4 minus 2 factorial, which will give us 24 here, and here we've got 2, and here we get 2, so that will be 2 factorial times 2 factorial is just 4, which will give us 6. Number 2 is 8, then 5 there. So we have 8 factorial over 5 factorial, then you have 8 minus 5 factorial. So what is 8 factorial? You can, I don't know if you use calculators, but you can just multiply quickly. So for me, it's giving me 4320 over. Here we are going to get 3 factorial. And 3 factorial is just 6. And what is 5 factorial? All right, so it's 120. Then 120 times 6, we get 720. We can now divide. Just use a calculator. If you can't, just cancel there, start dividing one by one. But for me, I'm getting 56. All right. 3 is 12, 1. So this can be written as, okay, so we have 12 factorial. Over here, we have 1 factorial. And we're going 12 minus 1 factorial. So, well, the only thing here is to do the 12 factorial, right? Now, I don't want to bother with a lot of stuff here. So, well, this is just 11 factorial. Then you have got 1 factorial there. So, if I remove 11 from here, you understand that 12 factorial can be written as this over 11 factorial. So those will cancel to give us 12. Simple as that. So you need to be a little bit creative. That is what we expect from you. All right. This should be question 4. That is n. Then you have n minus 1 fact. Oh, sorry. So n factorial over n minus 1 factorial, then n minus 1. Are you getting what I'm saying here? The number on top is n minus 1, n factorial over. We come up with this one next, the same way we have 1 factorial. This is the entire. Then you have open brackets. Then we subtract 12 here is 12. Here's n. Then minus this part here. That's what we write. All right, so what do we get now? We'll just end up having n factorial over n minus 1, if I'm not mistaken. There, you can correct me, please. So here we get negatives, these cancel. There and there we get positive 1. So this gives us 1 factorial, which will give us n over 1 there, it's just the same as n minus 1 factorial. But I can still, I can still work out this. It's not intact. I can write this one as n. If I take the next factorial, it will be n minus 1 factorial over n minus 1 factorial. So gone. So the answer here is n. That's wonderful. How beautiful. All right. 11 is telling us to show that question 11 is telling us to show that n is n that is equal to 1. Okay, that is what it's telling us to show. Now, it's not something that is difficult. We've been doing this. All right, as far as I'm concerned, let's go. Let's punch it. Let's do the putting in. So this will be, so n will be equal to n factorial over n factorial or divided by n minus n factorial, right? That we are very much aware. Then this will be n factorial over n factorial. Then we've got 0 factorial, because here is just 0 factorial. All right. Okay. So this one gone. So we have got 1 over 0 factorial. What is 0 factorial? 0 factorial is just 1. And the answer is 1. It's done. You've shown. But you also have to show that n0 is also equal to 1. Let's go. So n factorial over, what do we have here? 0 factorial, n minus 0 factorial. I have factorial there, 0 factorial. What is n minus 0? Still n factorial. There and there gone, we have 1 over 0 factorial is equal to 1 over 1, giving you 1. Hence, we can say thus, it's up to you. Whichever conclusion you are told at grade 10 by your English teacher is equal to 1. You have to prove that this is equal to 1 and that is equal to 1. Then you conclude. All right. Next is question 12. All right. So question 12, write down the binomial expansion of 3x minus 5y to the power 7. All right, so it's up to us which one we want to use. Okay, it's up to us. To be quite longer, but if you can use binomial, okay. You are not restricted to use. You can even use Pascal's triangle. If you want, you can use the binomial theorem. Whichever you're comfortable with, you can proceed. All right. All right. So let's do this. Let's use the binomial theorem. All right, because like we can sum up everything. All right. So it will be quite longer. All right. So 3x minus 5y to the power 7, like that. Okay. So we can sum this all the way from k equal to 0 all the way from k equal to 7 there. So we are summing 7 combination 0. All right, and we get 3x to the power 7 minus k, and we get negative 5 to the power what? K. I don't know if you are aware, but we usually have, for example, let's say a x plus b, something like that, to the power n. We usually have n k, we get a to the power n minus k, then we get b to the power k. You remember this? Yes, this is what we are going to apply there. So now remember that we are summing all the expansions from 0 to 7. All right, all what we need to do is that we can start from k equal to 0, k equal to 1, k equal to 3, k equal to 4, all the way up to k equal to 7. So let's start from k equal to 0. All right, so from k equal to 0, so we get 7, 0. Then we get 3x. So k 0, that remains 7. And here negative that one, we get 0 there. This will give us 7 combination 0 is just 1. Then here we get okay, to 18 x to the power 7, yes. Then there we get 1, which will give us 218, or 7 here, sorry, x, 7x to the power 7. You keep that one, you go to when k is equal to 1, you do the same. You go when k equal to 2, you do the same. You're just plugging in there. You go up to k equal to 7, then you add them up. That's all. That's all. That's all. All right, so I didn't want to waste much of the time here. I've just shown you what to do. So just keep on replacing what k there. You find, you keep, replace what k here, you replace, just like that. So here you'll be changing from 0, you put 1. If there's 1 here, there will be 1 there, there will be 1 there. If there's 2 here, there will be 2 there, there will be 2 there. I think you can fail to find that. Then add them up at the end of the day. If this is a tiresome procedure, you can actually use the binomial, the other one, all right, theorem, where you expand the one that starts with let's say a x, let's say, plus b to the power n, where we start with a n plus n minus 1, then b, like that, plus n minus 1, n minus 2, b squared, over to until, so you can use this one until per 7. It's fine, whichever, but I think the answer will be the same.